We, the Indian Society of Heating, Refrigerating and Air Conditioning Engineers, ISHRE, stand tall in the Indian industry with over 10,000 professionals as members and almost an equal number of student members. Founded in 1981 and headquartered in Delhi, we operate from chapters and sub-chapters spread all over India, bringing our entire industry together. Individuals become members of our society according to their professional and academic standings. Our roadmap of the future looks very bright, with thousands of new members joining this technical society every year and bringing in a fresh outlook to our industry intelligence. ISHRE disseminates knowledge through its technical committees, which consists of some of the best minds of our industry. It publishes technical books, newsletters, and a prestigious journal, distributing the wealth of knowledge to all its members. Working with government departments, ISHRE helps formalize industry codes and standards. ISHRE promotes research by offering financial support to student members to carry out groundbreaking work in technology, systems and processes. Our educational wing, ISHRE Institute of Excellence, organizes training programs and workshops to help members enhance their skill sets. Our specially designed certification programs under ICP, that is, ISHRE Certified Professional, empower professionals to always be in step with the prevailing technology. Specially designed courses for technicians are offered to meet the ever-increasing demand for a skilled workforce. ISHRE organizes exhibitions, conferences, panel discussions, and product presentations throughout the country. We organize the industry's largest international exposition in South Asia, Acrex India, to showcase the cutting-edge technology, innovation, and provide a platform for closer interactions amongst the decision-makers in the industry. The Acrex exhibition is now growing from HVAC&R show into BFA, Build Fair Alliance. This brings together several allied shows connected with the building services industry all at one location. Our chapters organize several other popular events like AgriConf in Delhi, Raycon in Kolkata, Symposia in Mumbai, TechFest in Goa, and many more. We are committed to provide training and career guidance to our student members through seminars, lectures, quiz contests and site visits. A-Quest, a prestigious quiz competition organized by ISHRE to catalyze the transformation of the budding engineering professionals. ISHRE provides a platform to potential employers to select student members for careers in HVAC&R industry at the ISHRE Job Junction. Young minds are made aware of the need for saving power, clean air, and sustainability. The K-12 initiative of ISHRE focuses attention on school students' development to inculcate a scientific fervor and help develop them into responsible citizens. Speedy information is imperative to keep moving forward in this hyper-connected digital age. Searcher, a specifically designed search engine, is now available, which allows access to a well-catalogued database on HVAC&R and building services industry with just a few clicks. ISHRE cooperates with various national and international bodies, industry, governments, academia, think tanks to promote the concept of sustainability, environmental protection, and energy efficiency and conservation. To enter and explore the universe of the Indian HVAC&R industry, log on to ishre.in that unfolds a panorama of information Let us engineer a sustainable future together through ISHRE.
Good afternoon, everyone, and thank you for joining this workshop. Just yes, sorry. Good afternoon, everyone. On behalf of Delhi chapter of ISRE, I would like to welcome everybody here in this workshop. Today we'll talk about duct sizing, friction loss, and fan selection. This program is organized by Delhi chapter of ISRE and is sponsored by Western Air Ducts India Private Limited. And of course, today we have expert speaker Mr. E.R. Murlikant with us. So, on behalf of Delhi chapter of ISRE, I would like to welcome him in this forum, and we are thankful to them for taking out the time in his busy schedule. A few lines I would like to say about Mr. E.R. Murlikant, then we'll go ahead with the PPT that we have today. Mr. E.R. Mullikant is a mechanical engineer with more than 35 years of experience, presently working as a freelancing consultant, providing consultancy services in HVAC, fire protection system, storage tanks, utility and chemical process piping system. He is associated with some of the leading architects and MFP consultants in Chennai, mainly for clean room and hospitals. His core area in HVAC are clean room design, low RH system requiring lower than 15% RH, processes, process flue gas treatment for chemical factories, dust control system for powder handling processes, and HVAC integration with the fire protection system. He has been working with different industry in past 35 years, mainly with the chemical factories and pharma industry where indoor as well as exhaust air quality both are important. He has given some training program in the past few years in ISRE Chennai chapter and also to directly to some reputed HVAC companies in Chennai. All topics on clean room and RH for industrial application. He has written 5 articles on various topics in East General for the period of 2020 to 2021. So thank you, Mr. Mullikan, for joining with us. So before going to Mullikan sir, I would like to share one disclaimer slide. I don't want to read. This is the protocol that we show in this forum. So thank you once again. Without wasting time, I request now Mulligan sir to proceed with the PPTs. And meanwhile, I request every attendees to send your question in Q&A section. At the end of the PPT, we'll take it one by one. So over to you, sir. Thank you.
Yeah. Good afternoon. Thank you, Ishre, Delhi, and all the participants. It was a nice intro. I thank you very for the introduction. I think this opportunity I'm getting after a long time with Ishre Delhi to redo some of my learnings. Before we get into the program, I would like to give some small tips. See, we have got an accredited system, chiller, VRV, pumps, chill water pumps, mainly associated things. But ducting is the main thing which many people are having a lot of ideas. Some ideas are quite good, some are impressive, some are not impressive in look wise. But when you go into actual performance of the ducting and the probable energy saving potential, we don't gain much if not properly designed and installed. So this emphasize I would like to bring in here with a few examples and a few calculations through which you can be conversant or have little knowledge when you talk of ducting. See, ducting has got two components. One is the fan part, one is the duct part. So they both have to share together. If the fan selection is proper, you assume, and ducting is not proper.
Sir, can you please share your screen? I mean,
Yeah, I'm coming to that before that.
okay, okay,
Yeah.
okay,
So I'm
please.
just giving the outline. Yeah.
Okay, okay.
So okay. Now the thing is, so I have if fans are somebody may say fan is correct, somebody may say duct is correct, all those things are there. So when you want to properly integrate these two things, only then we can get a good energy saving potential. So this is the message I want to convey. Yes, aesthetics and all things are different part of the systems, which I do not want to go into much. Our prime thing is the ducting selection should be proper with energy efficient design. That's what our prime importance is. Now let us go to the uh, presentation. I'm audible to all of you.
Yes, sir, it's fine. You can
Fine.
share your video as well. Somebody has
Uh,
messaged me that they do not want, they are not able to see you. So I think,
okay.
yeah, it's fine.
Yeah. So let me just go to the uh, presentation. Screen is visible?
Yes, sir.
Okay.
Perfectly fine, sir. Yeah.
Yeah. So the program has the following topics: definition of duct, shapes and characters of duct, duct sizing methods and parameters, friction loss in ducts, volume control dampers, grills and diffusers, fan selection, duct as energy saving and cost saving. So please note that when we talk of section 3 and section 4, that is duct sizing methods and parameters and friction loss in ducts. That time I'll take you to Excel calculation sheets where you can see how the uh, duct parameter varies with respect to CFM and velocity and what will be the consequences if you don't have a proper selection. So that also we'll run through while going to the papers so that people have a better knowledge of how to do what and when for proper sizing. Now, definition of duct. Most of us are aware, but I just want to give outline. In HVAC system, duct is a carrier for moving conditioned air using a fan draft into a guided path that may be used for ventilation, air conditioning, scrubber, exhaust, or any other similar application that is defined for the use. Common materials used for duct are galvanized steel, aluminum, stainless steel, mild steel, FRP, nylon, polyethylene, SDP, or similar material. Now, in this materials, we don't talk of fabric duct because fabric duct application is different, and that's a separate chapter altogether, which I will not touch in this subject. I repeat again, fabric duct is a different altogether. We will not be able to share this because it is not relevant in this. Now, shapes and characteristics of duct. Ducts may be very different size and shapes. Most commonly used round, rectangle, elliptical. Shapes and now round duct. This is very commonly used in nowadays middle days, but it's got its own good and bad. Now, air tends to take circular path very often, gives very good scrubbing and cyclonic effect, highly recommended for powder collecting system, scrubber, flue gas exhaust, process gas, vapor exhaust. Okay, a very low venturi, sorry, a very high venturi effect to get higher negative draft. Why the importance of round duct is when you go for a scrubber and other similar applications, high venturi is required to pull all the vapors and flying dust, everything. Hence, this round ducts are very, very advantageous in those sections. Okay. Now, elliptical ducts, air tends to save circular path very often, give very less scrubbing and cycling effect because to get a cycling effect, there should be proper radial flow and should have high centrifugal force, which does not happen in elliptical ducts. Not recommended for powder collecting system, scrubber, flue gas exhaust, process gas, vapor exhaust. So these things will not applicable for elliptical ducts. Then we have rectangular ducts or square ducts, which is commonly used in most of the applications, especially in comfort. Air tends to take circular path very often, but restricted due to sharp corners. This figure is, see, these sharp corners is there. There will be too much of turbulence, so the centrifugal effect will be very poor. Cyclonic effect will be very poor. Hence, this rectangular duct is not preferred in for this powder handling, all those things. In comfort application, is all the three have good performance, no issues. In comfort application, hotels or restaurants or commercial buildings, you can go for a round or rectangle or square or elliptical, whatever you want, depending upon the space available to you. One message is popping up. Please move this window away from. I don't know what is this. Can anybody see this message?
Hello.
Yeah. So please move this window away from. Which is, I don't know where it's coming from. My computer. I don't know where it's coming from. A small
It's from
square.
your computer only, sir, I think.
Oh, from my computer. I
Yeah.
don't know. I don't know how it's coming. Okay, let me see. Let me try something. It's still coming that way. Please move away from what is. I don't know. I don't know what's the problem. Okay, let us go ahead. I don't know. Okay. Now this rectangle duct has got this uh, very poor cyclonic effect and very poor centrifugal effect. Hence, it is not preferred in for the say applications like scrubber, all those things. Okay. Now, one more thing is in air washer, many people go for rectangular ducts. But what happens is settling of heavy dust particles and also water droplets in the case of air washer and high RH applications. We actually don't recommend, but people go for it. I think the centrifugal force, when you go centrifugal force study of air movements in these ducts, the rectangular duct has got this drawback. When you go for air washer and all, no, this air water droplets will go and settle in these corners and it'll promote settling of ducts, dust particles and other things. So for when you go for air washer system, preferably go for a round duct. This is my suggestion. Now, design of HVAC ducting. The airflow pattern in ducts mainly depend on geometry, that is shape of the duct, velocity of air in the duct, type of branch connections in the duct, available static pressure in the air path, size and location of terminal grills and diffusers, internal finish roughness, and duct materials, etc. So, when selecting the material and geometry of the duct, we should be aware. When you have say 120 GSM GA sheet or 240 GSM GA sheet, of course 240 GSM sheet will be a little heavier and little costlier, but it have a better finish and lesser friction loss compared to 120 GSM GA sheet. But it is nowhere specified in the standards or any material which says this is the friction for this GA sheet. It's nowhere specified. It's only on assumptions we go. Uh, Mostly in comfort applications, supplier duct is much important. In many cases, return duct is not designed and not installed. This is a special topic I would like to emphasize. When we go down the other slides, it will be definitely be able to know. Somebody is raising a hand. Any question, please? We not too many questions. At the end of session, we'll go through the questions. You can put in the Q&A, but any doubts? Am I audible? Hello?
Yes, sir. Should we allow him to speak right now?
No, no, only one. See, three, four people are putting hands. I don't know. That's why I'm asking. It is only a hi, hello, fine. If it is some specific questions, that is not entering into too much of discussions. Okay, I think it's only question and answer. Then we'll go a little later then. Okay.
They can put their question in Q&A. I think.
Yeah. See, I was coming to return duct. In many cases, return duct is not designed and not installed. The reason being, the space above false ceiling considers return air freedom, and through a small opening in the H room wall, return air duct requirement is met. This is, however, a wrong practice unknowingly adopted by many designers without aware of the energy loss in the system. I will brief you when you go down the other slides. In many cases, what we do, architects, they say return duct we don't want put is a cost saving and all those things, but it has got a very large impact on so many factors. I'll explain you in the coming pages. Now, any duct shall be adequately designed to have smooth airflow, less friction loss, less energy loss, very little resistance in the air part to have uniform air distribution, very low noise, that is as low as possible, have least or no particle accumulation in the air path, very smooth curves for bends and branches. We are not going to talk into geometry or fabrication details, what will be the angle, what will be the radius of curvature. These things we are not going to talk because that is a separate standards and SMACNA defines all those requirements. So we'll be talking, as said a few minutes back, we'll be talking only on the energy point of view. If you have proper ducting, what will be the energy saving potential? Now, some concerns in duct design. Some common issues that come up when design ducts. Space above false ceiling is very less because architect has already decided this much space I'll give you. You have to put the duct, and we do whatever possible in that. Client prefers only round ducts, yes, good. Some prefer only electrical, fine. Some people with internal insulation, then client design is not for return duct. People they not why to put return duct, why to put the money on that. So that's the thing. Return duct is removed from scope for cost saving. Earlier it was in the tender, it was later deleted just for cost saving. These are the concerns in ducting design. Now, for effective ducting, the following factors are to be looked into and considered properly. Air velocity, we know Q is equal to area and airflow. Q is equal to area into velocity. Airflow can be CFM, that is cubic feet per minute, or CMH, whichever unit is used. Area, duct cross section is square feet or square meter. Velocity in FPM or a meter per second, whichever units we want to choose. Friction loss in duct, these are very things. One is how much flow you want, friction loss in duct, friction loss in dampers, friction loss in diffusers, and friction loss in filters. Now, duct size calculation. Flow is equal to area into velocity. For example, 10,000 CFM, velocity 1200 FPM, Q is equal to A into V. Area shall be this much square feet. Round duct is almost 10 inches. And rectangle duct, if you have an aspect ratio of 3:2, then it will be 1100 by 700. So aspect ratio also is very, very important while taking the duct sizing. That also I will brief you when you go into the Excel calculation. So you'll have an aware of how the things are behaving. Now friction loss, yes, many people are not aware of this formula because it is a very old formula and people just go by software and all things. But we should know this formula to arrive at the pressure loss. Why pressure loss is important? Because it has got the relative importance of selecting the fan static also. Fan static is selected by friction loss on the duct, filters, and we have cooling coil, heating coil, mist eliminator, etc., damper. So fan static shall be total of all those things. But ducting is something which people go by assumptions, go for 20 mm, 40 mm, or 30 mm. Just like that, people go, which is not the appropriate correct method. So this is the formula for that. dP by 100 feet per 100 feet is equal to 2.56 into 1 by d or 1.18 into V by 1000. Okay. D is the duct diameter. Okay. Duct diameter. If you say rectangle duct or elliptical duct, it will be converted to equivalent diameter. Now, area is equal to pi d square by 4. So if you have a 4 square feet area in rectangle, you can easily apply the formula pi d square by 4 and get the equivalent round size. Some people may ask what is the difference between rectangle duct and round duct, how much friction loss there could be. See, there is separate formula for round rectangle also, but we are not going in depth in this because it's a separate topic. When you go for round duct, we generally not only take off this velocity of the air, we also take into the weight of the dust particle when you're talking about scrubbers and powder handling systems. So there, this formula gets corrected to some other way. So the dust particles also are captured for the velocity or vacuum pull created by the fan. So that we are not talking here. That is special application. Now this is the CFM of air, velocity in FPM, aspect ratio, duct size, duct length, pressure drop. Now I will take you to the Excel sheet now so that you'll have an idea how it is behaving. I'll just take a small break here and go to the Excel sheet. Now this is the formula. Okay. Now I will just see here. This Excel is visible. I will share it now. 1 minute.
No, sir, it's about to come.
Yeah,
Okay.
yeah. I'll show 1 second. Yeah.
Now it's coming, sir. Yeah.
It's coming now.
Yeah.
Okay. This is for a rectangle dot. Similarly, I got round dot also have here. Okay. Now just carefully watch this formula, how it is behaving. Okay. Now we have add data, how much flow you want, how much FPM velocity you want, aspect ratio for rectangle ducts. Now this last one is the actual pressure drop. Okay. This insulation quantity, I'm just for the time being, I'm hiding it. Okay. Now say suppose I put here 5000 CFM, okay, and I put here this is the velocity of say 1200 FPM, okay. Now aspect ratio I put here 3 5 is to 3, sorry, 5 is to 3 aspect ratio here. Now this is my duct size, okay. Now see this is 1000 mm, this is 375 mm, okay, and duct length I am putting a 35 meters, okay. Now this is the actual pressure drop. Are you able to see here?
Yes,
You will
sir.
have,
Yeah.
this is the pressure drop. Okay. Now, now this will since the size is big, it is now going for 22 gauge sheet. You are seeing here now. Okay. Aspect ratio. I told you how it's important. It is going to 22 gauge sheet for this duct. Okay. Now I am changing it to say 4 is to 3. Okay. Now see the velocity is now actual pressure of how much is coming? 1.85. Now I am changing this velocity to say 1500. Okay. Now it's coming number 3.26 pressure torque. You are able to see this now? Correct? See 1200 FPM. Okay. CFM is same. Okay. Duct length is same, 30 meters. And actual pressure of 1.85 mm. Now if you put it 1500, it's coming to 3.26 mm. If you're not able to understand, I will again copy this further down the line. I'll put here different velocities and show you. This 35 meters I'll keep same. Okay. Now CFM is same. I put here say 1000. Then I put here 1200. I put here 1400. Now 1600. Now 900. Okay. Then 1300. 1900. See everywhere. See how the pressure drop is changing. My CFM is same. I have not changed the CFM. Aspect ratio I am keeping the same. Duct length is giving the same. Okay. Now friction loss here 1.3 is 594, 6.19. How it is changing? So when you have got a good network of ducts all around, you can just imagine by sacrificing on the velocity, how much pressure loss you are likely to face in the duct. So higher the velocity, higher the pressure drop. Length is, I'm seeing again here, 5000 CFM. Now I put it, say, 2000 CFM. Okay. Now this is now 63, 24 gauge. It's from 24 gauge now. Okay. 2.27. I put here 900, 1.75. So now I was telling you about aspect ratio. Okay. Now if I put here 5 is to 3, See here the size is 600 now. I put a 5 is to 3. Sorry. I put a 5 is to 3. Now it is again 22 gauge. I put here 7 is to 3. It's coming 22 gauge. Okay. Now why I want to say is important is now which is cheaper? 22 gauge, 24 gauge. 22 gauge naturally 24 is cheaper, 22 is higher cost. So the false ceiling, somebody has already crashed the false ceiling to less height, and you're forced to go for a thin ducts. You are having this much ratio 7 to 3. Okay, now your width is 1000, height is 200, and what is your gauge now? It is 22 gauge. Instead of 24 gauge, you have to go for 22 gauge. Here is where the cost also comes into picture. Now let us say for round ducts. Okay. Now this also very interesting. Now here also what I am putting here is the CFM. I will put the same. FPM I will keep changing. Length also I will keep changing. Okay. Now CFM I put here say 8000 CFM. Sorry. 8000 CFM. I put here say 1400, and duct length I put say 13 meters. It comes to 22 gauge because it is more than 750, 22 gauge, and 1.98 is the friction loss. I put here 1000, it's come to 0.83. Okay, I put here 700, 0.32. So this is how actually it varies. So now coming back to this PowerPoint. Okay. PowerPoint is saying no.
No, sir. Still about to come PowerPoint.
Saying now?
Yeah, it's coming, sir.
Okay.
Please go to the slides.
Yeah. So now we just took a comparison how the friction loss varies with velocities. The Excel, I think people have not understood. When your velocity is the same, I mean flow is the same, velocity I am varying, aspect ratio I am fixing some aspect ratio. Now pressure length I am having something. For same CFM, same aspect ratio, same length. Just because of the velocity, the pressure drop of the duct is varying. Okay. Now duct and grill diffuser positioning. It is always important to identify proper location of grills, diffusers, duct routing, duct spacing, and importantly, the aspect ratio. Just few minutes back, I told you the aspect ratio, how the duct sheet size is changing just because we have changed the aspect ratio. Instead of 22 gauge, we are going for 28 gauge or some up or down gauge because the aspect ratio is uh, not proper. Now, we now show the duct routing grill positioning. For effective air circulation, effective coverage of air, flow and equilibrium across the rooms, it is important to identify and plan the ducting. Improper grill diffuser position will have more thermal disbalance in the room, resulting in ununiform comfort level amongst the occupants. Now, this is the three options. This is a room, this is shaded or supply grill, this is unshaded or the return air grill. Now, in the first option, uneven thermal equilibrium closer to wall. This will be having a hot spot. This will be having cold spot. Okay. Now, second option two, uniform thermal at all point because it's sort of zigzag. Okay. It's not. Now, option three, ratio of supply return is improper. Duct air flow dissipation improper. Like this. Velocity of very high velocity. Now, So option 2 is why I am saying uniform or better than option 1 and 3. Let us evaluate. Here the number of supply and return are identical. Okay. Here the supply is more and return is less. Now what will happen is if you don't have a proper return or duct sizing, there will be supply air velocity will be lesser than return air velocity. So there will be whistling noise in the room. What generally people do is they put some FPM and size the duct. But what will happen is in this distribution, the noise will be high and return air will be pickup will be high and thermal equilibrium will be poor. Whereas in this case, it will be much better because crisscross directions is everywhere it is throwing. So this is how we should actually plan the. Of course, aesthetics also important. In between, you can plan the lamps, I mean, ceiling lights or whatever it is. This is a rough estimate. Now, some people say, why if I give a supply grill here and return a linear grill here? Again, the question is same thing. As long as there's a distribution balance, no issues. Otherwise, you'll have a problem. Now, role of supply and return duct. Role of supply duct, we are aware to give condition and to the room. Why do you require return duct? Many people do not design and install return duct. Any significant effect? Yes, there is. Will in the coming days, I will tell you what is the effect of not going for return duct. See, here is the typical installation. Here is the AHU room. You are having a supply duct and row return duct. What will happen here is the space above the false ceiling, although considered as a return or plenum, it is not considered in the heat load. Very important. We generally calculate the heat load up to the false ceiling only, and other above the false ceiling is generally not taken into consideration. Now, what will happen here? This air, since it is not considered the heat load, it will also have some heat, stored heat, or picking heat from different sources above the false ceiling. So all this heat will travel to the AHU coil only. So instead of 20 TR coil, you may require 22 TR, 24 TR coil. And this problem actually when you come to face mostly in summers. Because summer, this effect will be felt very high compared to normal seasons. What happens in summer? People will tell AC is not effective. The AMC fellow comes, cleans the filters, goes. By the time summer is over, situations are again coming to normal. In peak demand is always a headache. In peak demand, always a headache. One more issue is in rainy season, plenty of condensation will happen on the space above the false ceiling. This condensation will damage the false ceiling and also promote fungal growth. Especially in clean rooms and hospitals, this fungal growth is not a good thing. So these are the various things. Now, I explained you consequences of not having written down. Say we have 6,000 square feet area, false ceiling is 10 feet. Gap above the false ceiling is 3 feet. The cooling load workout is close to 40 feet here for the given area and ceiling height of 10 feet. Since there is no air duct, the return air duct picks heat from space above the false ceiling. This additional heat attracts approximately 10 to 12% more load. In top floors and unducted insulation is not given, this load goes higher by another 4 to 5%. That is, instead of 10, it will be 15% roughly, especially in daytime in peak summers. The top floor is there and unducted insulation is not given, add to unwanted extra load. The simple reason is mismatch of actual TR with respect to dehumidified CM. For say for dehumidified CFM, you want say 10,000 CFM, but because additional load, the starvation of cooling effect. Now, scenario 2, there can be some openings above the false ceiling entry for cables or fire pipes, etc. In this very common scenario, suppose in the same floor you're having a washroom. Above the washroom, the wall will not be built. It will be stopped up to the false ceiling only. Say I want to save the brickwork of maybe 3 or 4 feet height. The entire duct is passing over the false ceiling. So this gap above the bathroom will be pulled by the air to in the return duct. What will happen? This had the load again. So these things are very very common thing. People, the builders, they don't put the wall above the false ceiling for the washroom. Say what is there about that? So it has got significance. When you are planning a building without return duct, for ceiling expect to work as a return duct. Please take care that you build the wall wherever required and close all the openings like cable entries or fire pipes or plumbing pipes or anything like that. Otherwise, what will happen? All the air above the false ceiling will find n number of spaces to raise the temperature, humidity, everything in the conditioned space. Now, in scenario 3, I told you, rainy season, the trapped moisture above the false ceiling comes in contact with cold air. This promotes heavy water condensation above the false ceiling. This leads to growth of molds, fungus, etc. Filling of ceiling paints. The dehumidified CFM is not computed for the additional volume of air trapped above the false ceiling. As I told you just few minutes back, this we calculate up to here only. This many people avoid in calculation. So this load will automatically add to the system. Now, aspect ratio. I am again going back to the Excel sheet so that you can recollect what we discussed. Are you visible?
Yes, sir.
Yeah. Aspect ratio. Again, let me refresh your memories for a file. How aspect ratio is varying. For 2000 CFM, say I am putting here 3:2. Now, this will be a duct size. Okay, I am highlighting this in separate color so it is easy for you to recognize. Yeah. Okay. Then I put a same 1100 velocity, same here I put here. So the velocity already discussed. I just putting the aspect ratio only. Velocity I am saying here, CFM I am having same here. Aspect ratio I am changing. This and all pressure drop I am not talking right now because we just discussed about pressure drop. Okay, now this gauge size you see what the gauge size and what is the uh, um, this one duct size. Okay, 3:2. I put here say 4:3. Okay, coming gauge size is now still here only. I put here 2:1 like this. Okay, now I put here 5:2. See here, it's now gone 20 gauge now. Okay, correct. I made it 5:2. It's gone to 20 gauge. Till now it was 22 gauge only. The moment I change aspect ratio, it is gone to 20 gauge. That means where the sheet cost is high. Here up to here, sheet cost is okay, 22 gauge. But once it changes, it goes to sheet cost goes high. So this is a very very important thing. I am going back to again this um, Excel side. PowerPoint again. I'm going now. PowerPoint is seeing now. Hello. PowerPoint you are seeing now. Hello. Hello. Something audio thing. PowerPoint is seeing now.
मेरे को तो ये लग रहा है कि इसमें
Hello. Hello.
Hello.
Yeah, PowerPoint is seeing now. Yeah.
Yeah, fine, sir.
Okay. So uh, We discussed the aspect ratio now. The example Excel sheet we briefed how there is changing. Okay. Now, meantime, note the false ceiling, true ceiling, all decided by the architect. Within the available space, ducts are to be installed, including space for other services like fire, electrical, drainage. So this we saw how the aspect ratio is making your duct cost go high or low. What happened here? Stop. Sorry. Wait. Something wrong. Something wrong. Let me reopen the file. Something wrong. Let me open the file. Wait a minute. Sorry, excuse me. Let me open again. Something wrong, I think. Please, sorry, bear with it. You're saying now?
Yes, sir.
Hello?
Yes, sir. Design of HVAC ducting.
I think something wrong with that. Suddenly it got stuck up. I don't know.
It's coming now. It's fine.
Coming now?
Yeah.
Okay, fine. Suddenly it got stuck up. Okay, fine. Okay. Now, let me go to the now aspect ratio we saw, correct? Now, volume control dampers. It is important to provide volume control dampers in all branches for both supply and return. Few issues without volume control dampers. Airflow cannot be evenly, sorry, my mistake, cannot be evenly adjusted across all branches. Uniform air distribution gives better thermal equilibrium for all multiple locations shared by common AHU. Excess airflow in some portions gives higher noise and higher friction loss in that particular depth segment. Without dampers, flow is not adjusted, hence higher lower velocity in various duct segments. This imbalance of velocity varies the friction loss. This can affect the stand static selection also. In that case, the farthest room shall not get adequate airflow per hour and the temperature band is disturbed. This also reduces fresh air mixing to the farthest point since most of the air is distributed at the beginning of the AHU. What I mean to say is, if you don't have a volume control damper, suppose one AHU is distributed into multiple rooms and there is no volume control damper. The first room will get the good flow and the farthest room will not get adequate flow. Will be proper, there will not be proper air balancing and thermal equilibrium will be disturbed terribly. One more thing is the first room will get the very good fresh air because it's come the first point and the farthest room will get less fresh air. So all these things are there. So volume control dampers, people may say I say 5 rupees or 10 rupees on this damper, but actually we are not supposed to do that. We have to put volume control dampers for all duct branches. Now grills diffusers shall be positioned to have good airflow into the room, good aesthetic, minimize dead pockets, have better flow towards the room corners, especially in cool rooms to avoid particle settling. Again, many people do not give volume control dampers in the grills diffusers. The role of damper in grill diffuser is similar to that in the branch duct also. I'll just show you how it is important. Now, grill diffuser without VCD. Uneven air distribution. This picture is clear, all of you? This first grill is getting good air, I mean good quantity of air, and the last grill is having only very less air. So what will happen is this point will be warm, this point will be cold. cold. It will be around 2.5 degrees centigrade difference roughly in large rooms from this point to this point. So what people will do, they will put some additional wall mounted fan or ceiling fan or table fan to make themselves comfortable. You are spending some money for the table fan or ceiling fan since you have not put any damper here. It's a recurring cost. Every month you have to pay some money for the EB. Okay. With collar damper here. The earlier was without collar damper. It's with collar damper. Next sketch. So you have uniform distribution, almost no hot spots. So in this air balancing will be very, very easier. You'll have uniform air distribution throughout. Oh, somebody may ask, why not put reducer here? This only is schematic diagram, not a dating diagram. Actually, what you do after every few groups, you have to reduce a duct cross section, which is we are all aware. I am not going into the details because it is separate discussion, lengthy discussion, how to do, what to do, and all. So here, as I told you, we have to focus on energy saving only. So here we will not have good energy saving because lot of air is getting heated unwantedly. This person will run fan for hours together to make him comfortable, whereas here that fan is not actually uh, used here. The fan selection. We already discussed about the friction loss. Compute the total friction loss in duct. Compute the friction loss in damper, grills, diffusers. From the filter catalog, select the pressure drop across various filters. Work out the pressure drop across coil and other elements in the AHU like heating coil, cooling coil, and UV lamp or whatever it is. Sum up all the values. Roughly 10 to 25 15% we take for the hidden losses. Okay, like branches, the T joints, and some unknown barriers coming in the systems. This will decide static pressure. This static pressure is the required pressure to overcome the resistance in the system. Velocity pressure is the pressure generated by the flow of air. It reduces gradually from source to the farthest point. So here, if your duct aspect ratio is not properly done, suppose you're having very thin, narrow duct, high velocity, initially the velocity pressure will be high in the first grill, and the last grill there will be very low velocity. The velocity pressure is very much essential to define the air path with proper distribution. Otherwise, what will happen is some places you will have good air, good amount of air, some places you will not have good amount of air. So this is what a very important thing. People has to have to pay more attention for the calculations rather than going on assumptions and some thumb rules. Now, fan selection. See, here is where the fan selection. Now, for example, say we have a 20,000 CFM fan and static 80 mm. Okay. Now, how to select the fan? If you have a fan selection software with you, fine, or you can demand from the fan supplier, Kruger or XYZ, or the HU's fan supplier to submit their fan selection with different model options. So here, for 20,000 CFM ATM static, we have multiple models: 630, 710, 800, 900, 1000. Now, each fan will give different velocities: 14.75 meter per second, 11.7, 9.3, 7.3, 5.89. Now, what is the fan RPM? Here is where we actually save on cost and also the running cost, both. How? I will just brief you. Now, here in this model, 1800 model, the fan RPM for the selected flow is 965 RPM, which is giving you efficiency of 75.8%, and big AW 10.4, motor kilowatt is 15, and motor RPM is 960. So we don't want to put any pulley here. It will be direct driven because pulley will also have some friction loss, rebuild loss. So this is first thing we are getting advantage of this. Okay. Now 900 also can be preferred, because efficiency is not that much difference. But here you have to pulley. So when you put pulley, this motor RPM is say for 960, and here is 800, the fan RPM. You can put a small pulley and reduce it. But what happens is many people ignore this motor RPM. They blindly go for a four-pole motor or a two-pole motor, which is commonly easily available off the shelf. In this case, if I put 1440 RPM for both the applications, my pulley loss will be higher because from 40 or 1440 I had to change to 960, put a Weber loss, everything will be here. But if I directly go for a uh, uh, six-pole motor, which will give 960 RPM, it is okay for me because 960, 965 is absolutely very close by, no issues. But here is what people actually are not aware. You know, we got two pole, four pole, six pole, eight pole. Four types of motors are available. Eight pole is a 720 RPM, six pole is 960, four pole we are aware 1440, and 2850 is a two pole. So not only the fan selection, even the motor selection or the that particular pole 2, 4, 6, 8 also has an impact on the energy saving potential. If I have a 1440 RPM motor, unnecessarily I put a pulley and increase my friction loss, then fan selection will be of no advantage for me. So here is where energy saving we are able to see. Now, again, I discussed the fan optimum velocity, optimum efficiency as much as possible close to motor RPM, variable possible off for direct coupled motor. See, plug fans also you can consider if the fan RPM is close to the plug fan RPM for the rated capacity. Putting a VFD and trying to reduce RPM has got its own advantages and disadvantages, which is a separate topic altogether. For an outline, I'll tell you, everybody says motor is VFD compatible. However, please note that when you want to increase or decrease RPM momentary for maybe half an hour is fine. But when you lifelong want to run the motor at a lower frequency, it is not advisable. For example, for a selected fan, you want to run the motor at 40 hertz lifelong, then it is not advisable. So separate topic is a VFD. In when coming programs, when you get a chance, we'll talk in deep about that. Now, duct test energy saving. Now we discussed the friction loss and some calculations were demonstrated. You know how the important is the velocity because velocity if it's higher, friction loss is higher. Friction loss higher means BKW higher. Then fan model, everything adds on, adds on. Friction loss, calculating ducts, pressure loss in filters, coils can optimize the fan selection. We discussed 20,000 CFM fan, 8, 10 to 11 BKW, 15 kilowatt motor. But if the fan had worked out with 65 mm, then BKW with 8.9 kilowatt only. So we can directly, instead of putting 15 kilowatt motor, 11 kilowatt motor we can put. So what people we do, we don't uh, do proper exercise about the fan static selection. Somebody says 50 mm, other bank will say in that project I put 80 mm, so put 80 mm. And we blindly put 80 mm. But actual recommend 65 is okay for us. But we put 80 mm. The what we are doing instead of 11 kilowatt, we'll be spending more. These are the consequences of opting for uh, wrong selection of fans. So for same case, if I'm running 24/7, they'll be saving of 40 units per day, close to 17,500 units per annum. So you can imagine what will be the cost of this. If you have multiple fans similarly working this way, can you know what will be the saving? So already we spent on over design by putting 15 kilowatt motor and again burning energy. If you optimize 11 kilowatt motor in the design and project stage and run at this, you have a good saving. So return duct is very, very important. Sizing is important. Insulation, everything is important. So let us not take this ducting as a very meager thing. It has a lot of value to play. In air conditioning, every component has got a value to play. Chiller, we generally talk of chiller, pump, piping, and other things, but we don't uh, give much importance to ducting. These examples I am not correlating for ductable units. These are package units, ductable units which have a very low static of maybe 30 or like that, and it can throw up to 80 feet or so distance. So ductable package units I am not talking of because they're factory assembled and they got a different mechanism. This ducting is mainly for centralized air handling units which supply duct and return duct. Importance return duct I already explained. So we should make it a point to bring everything in practice. Now, duct as energy saving. We just briefly here. Return duct is given as least preference for proper fixing of gaskets, sealing joints, etc. Now, many people they put return duct, but they don't give importance for the jointing of ducts, gaskets. Because return, they say return what? Yeah, nothing will happen. In supply duct, there is a fan duct. You can feel the air bleeding out. If you pass near that, it will be hitting on you. You can feel yes, that is leaking. But return is in vacuum. You cannot see or feel vacuum. So if the duct flange bolt are not put properly, the gasket not put properly, what will happen? It will pull all the unwanted material from the surroundings and add to dust, it will add to heat load and everything. But it's not visible. You cannot sense any or see any return duct leakage. How will you build positive pressure? You cannot do positive pressure. Or you have to separately put a blower during the testing commissioning, pressurize the duct and identify the leakage is very impractical. So here, I want to emphasize is any leakage then it cannot be identified since it's vacuum. Improper sealing of joints, incomplete fixing of fasteners, uneven tightening of joints are all very important. Tightness of duct is more stricter than supply duct. The supply duct you can see the leakage, return duct you cannot see. Since RA duct is in vacuum, it pulls all unwanted wet air, dirty air, etc. from nearby areas, adding to heat load, moisture load. Especially in low RH areas, the air duct contributes maximum moisture load due to vacuum pull of outside air through small openings available in the ducts. So return air duct has a very good potential for energy saving. I think people should understand this and implement in at all locations, either be comfort AC or restaurant or a cinema hall or any establishment. The motive is to save energy. Now, summary: ducting is important component and design executed with proper calculations including thermal load, airflow, CFM, static, distribution pattern, grills and dampers, etc. The benefits we get are optimal use of cooling energy, uniform thermal equilibrium in the conditioned space, thermal energy saving with when giving return a duct above false ceiling, fan power saving by selecting suitable fan, duct material saving by selecting proper aspect ratio, noise and vibration reduction by considering suitable air velocity, and air duct leak proof tightness is important to manage the heat load, and this has the potential to save more thermal energy. I think my things are over. Uh, any questions from any participants? Please let us come across.
Yeah, thank you. And very many questions we have received, sir.
Yeah,
Uh, should we take one by one?
yeah, please, please.
Okay. The first one is what is the best duct square foot material required to cool one TR cooling?
Repeat once again.
What is the best duct square foot required material to cool one TR cooling?
See, duct material you can have FRP, you can have P8 ducts, you can have GA ducts or MS ducts. It suits whatever the client specifications or tender specifications. It's nothing saying that this material we should go. Depends on it, the application and the For comfort application, generally we go for GI ducts, and in some people we go for MS ducts also. Some people go for FRB ducts also. It depends on the customer based applications.
Next one is with decreasing velocity, pressure drop reduces, but material requirements and cost will increase. What is optimum value you recommend?
Again, I give an Excel sheet to you. When you decrease the velocity, your friction loss is also reduces. Now there are two things you have to see. One is the energy loss, one is the material cost. Okay. For a say you are running down from point A to point B of say 500 feet or so. In that case, you better go for lower velocity. The friction loss will be less. Otherwise, what will happen? The longest point you will not get the good airflow. So you have to strike a balance. What is optimal? See, in any comfort application, I would say up to 10,000 CFM, you go for around 900 to 950 FPM. 10,000 to 18,000, you go for maybe 1,000 to 1,200. And you go into more than 20, highest limit to 1400 FPM. Don't go beyond 1400. This is mine. It's because I've seen the various calculations. I'm just sharing few of my experience. When I do long installations, because AH is kept somewhere away, a room is somewhere long part away, the dust distance is very long. So there are some specific cases where we have to do such access in various industries. So in those cases, what we do is we preferably go for a low velocity to minimize the travel loss up to the entire building. Next.
Condensation is related to dew point. I think we have taken it. Yeah.
See, condensation is related to temperature first thing.
Dew
Lower
point
temperature.
hence when the surface temperature is above this, then why condensation takes place in return air plenum.
See, return air freedom. Because the thing is, I'm trying to there too. If there's no return air duct in the room, the grill is open to the above false ceiling. The cold air will get entrapped into the above false ceiling. Now, false ceiling space can be having mixing of air from different sources. We don't know where it is. And such a huge area, it's not taken the heat load. So this wet air, cold air will get into the space and promote condensation. It happens, especially in rainy days. In normal days, the condensation may not be visible. Normal days, not visible that much. In rainy days, definitely be visible. You feel that the room is being a lot of wet surface in the false ceiling. You can see that. Next, sir.
Should we take the next one, sir?
Yeah.
In your Excel sheet, what is the formula in cell calculating pressure drop in millimeter? I think it is millimeter. If acoustic insulation is used inside ducts, will pressure affect?
Yeah. If you are putting insulation inside the duct, that means insulation in most of the cases it's not having a smooth surface compared to GA sheet. The roughness is little higher. So your friction locks will go a little higher. In that case, suppose you are having 500 by 500 duct, you go for 550 or something higher size. That's the only way. Because insulation thickness you have to add and the roughness of insulation you have to add in the friction loss. And this formula is very, what I showed you in the PowerPoint, the same formula, that's it. I have not done any magic in that. It's a big formula. I can just uh, share it again. Not a big thing.
Next one, sir. What should be the phase velocity of grills for different throw, like 10 feet, 15 feet, and 20 feet?
Okay, grill velocity roughly we keep around 450 to 500 FPM for normal grills. But in your this what you call this jet diffuser. For jet diffuser, we go for 800 to 900 FPM. But the throw is very long. With a low velocity, you cannot have a good throw with a jet diffuser.
how to estimate static pressure of axial fan mounted in doghouse kind of shaft on ground serving the basement ventilation with jet fans. Usually 25 mm WG is considered roughly. How to judge properly the pressure drops through lower fans, lower fan sections, shaft, etc.
See, there is always, this jet fans kept in the basement. I mean, it is, I would appropriately say, it is just making uh, show, nothing. I got no contribution at all, unless you having ducting. In most of the basement, you don't see any duct. You have only some jet fans put here and there. Now, just scientifically imagine, as a scientifically imagine, the fan throws from here, unless it's given a path, it'll come back here only. So what is the contribution of jet fan in a basement without duct? It not so that it will be separating the basement only. These jet fans, I know who has brought it. I already had a number of debate with many people, and many people are convinced the jet fans in the basement for parking without ducts. Without ducts has got no role to play. Because send there from here again, come back to the same place only. Where it will go? It will only keep giving a churning effect inside the basement. That's all. So this I discussed with another people and they got convinced. So things in coming days it will change. Yeah, somebody was asking about the pressure drop. Here is the pressure drop formula. It has a big formula. Okay. Some value and all I put the same thing what I put in the PowerPoint, same formula. Say ultimately I converted it to of water column. That's it. The screen is visible, yeah?
Yes, sir.
Yeah. So this is what the formula is. There's nothing. The same water formula I showed in the PowerPoint, same formula I put here. So next question, please.
Hello.
Yeah.
Can you please explain for motor pole RPM details?
See, we have got four types of motors, AC motors, four pole, 2, 4, 6, 8. Two pole is 2850 RPM, four pole is 1440, six pole is 960, and eight pole is 720. These are the four types of motors universally available. However, if you want to two or three motors as a tender specifications, the two pole and four pole you get faster. Six pole delivery is little longer. Eight pole is little more longer because these are less demand motors. They are available, but two or three motors you cannot get from the directly from the dealer from the market. Suppose you want three motors of say 10 HP of six pole, he will say it'll take 3 months or 4 months. That's the catch. They are available in the market as per universally available, but delivery one or two motors nobody will manufacture. The manufacturing line for two pole and four pole are only very heavily booked. This is the constraint. Okay, next question, please.
Can you throw some light on normal practice for VRF uh, cassettes fresh air connection?
See, VRF and cassette pressure are different. See, in one of my earlier programs, I told very clearly, for example, is having 10 or 12 cassette ACs in a building with some TFA, maybe Daikin or Carrier, whichever brand it is. They have got a small hole for fresh air connection in the cassette. Okay, actually it doesn't have any purpose, fresh air component, because the fresh air static is very low offered by them, maybe 20 static or so, and it will not reach the farthest point. Okay, we only just put some pipe, that's it. What I always recommend is I don't put any direct fresh air into the cassette. I have a dedicated fresh air system with grills and ducts which will be throwing air at different spots with adequate static. Advantage is if I have a direct pressure port into the cassette unit, due to weather disturbance, what happens is there will be sudden flooding of water in the cassette, especially in the monsoon or like that. and if the pump is not working, water will start falling on the tables. So I to avoid that, what I always say is I put a small layer to give fresh air. All these indoor cassettes are not meant for high enthalpy sudden shocks. Suppose suddenly weather changes, the enthalpy goes high, and the cassette AC will not take that much load. So I never recommend this idea of putting fresh air port in the cassette ACs. Next, please.
What should be the aspect ratio for HVAC ducting?
See, the formula is very transparent. Okay, I showed you what is the thickness, how it is jumping, and what is the aspect ratio. If you're able to select it properly, you can save on material cost. Or your architect says this much only for ceiling height is there. You go for a very different aspect ratio. You cannot say my cost is going high. You have to bear with it. That's it. Either convince the architect or you convince yourself. Please try to know to use the formula aspect ratio so that you can uh, rightly choose a duct material size, 20 gauge, 24 gauge, or whatever it is. Anything, sir?
Can we move to the next one? Hello.
Yeah, tell me.
Can we next? Should we move to the next question, sir?
And question, yeah, please.
Yeah. So I think there is some question remaining in chat box. Uh, Out of this topic, what about the fair related rated duct specs and tests?
Yeah, repeat once again.
Out of this topic, what about the fire related, fire rated duct
See,
specs and tests?
fire, smoke ducts are different. See, we go for only this GI ducts, okay, with metal ducts because metals have got higher temperature resistance compared to FRP ducts or other things. Some people go for stainless steel also to avoid rusting and all things. Now, fire-rated ducts, you're going to have a very high cyclonic effect to pull all the smoke. So that's why in the starting of that, I explained the configuration of rectangle duct, round duct, and elliptical duct. So whenever you go for a smoke duct, dedicated smoke duct, then go for round ducts only with high velocity, maybe around 1600 fpm or so. Only then there will be high Venturi effect created and high vacuum will be created to expel the air very fast.
What is internal insulation of duct?
Internal insulation we already discussed. You can go for a nitrile rubber or like that. Only thing is the friction loss will be high. You have to go for one size higher or like that. Maybe 20 mm or 50 higher on next size to accommodate for the friction loss.
Can you please re-explain for motor roll RPM details? I think we have taken this question.
Yeah, yeah.
Yeah. Please specify what is the ratio for supply in duct and return air duct sizing.
Once again.
Please specify what is the ratio for supply air duct and return duct sizing.
See, either way, this is geometry, which means this much square feet of air should come, this much velocity you should have. You can go for rectangle or round or square or elliptical. It's up to your choice. That again, I'm telling you, aspect ratio. If you're having a very good aspect ratio, there will be material cost saving. If your aspect ratio is very not good, then your material cost will be high because the gauge changes. And CFM, you already work out CFM, how much I should come, how I should go. And velocity, please maintain with a low velocity, 1200 fpm, and not go beyond that. Otherwise, your duct price will go very, friction loss will go very high. You may save on duct aspect, height and width, but your friction loss will go high.
What is dead pocket?
Dead pocket is a place where there is very poor air circulation.
I Only few questions are left. How we can calculate electricity saving by duct leak seal?
See, there is no exact way of to scientific formula to prove how much energy saving will be there. But as I told you, return duct is the biggest culprit. Supply leakage is easily visible, and instead of 1000 CFM, you may get 900 CFM in the room. It's not a big thing. But return duct contributes a lot of heat load because in the vacuum it pulls a lot of unwanted heat from various surroundings. So as long as your return duct is leak tight, then you have got a energy saving. But no formula to as of now to evaluate how much saving will be there, because if no sweating means no the AC is good. That's why people have the mindset. If there is no sweating, AC is working. That's it. So in that case, you cannot define. Somebody had 25 degrees, somebody had 27 degree, or somebody had 22 degrees also. All these have a role to play in saving. But water temperature you set, the return duct should be leak free. That is the intention. Anything else, Tapasji?
Yes, sir. Many questions are still pending. Sir, please show the all Excel formula.
Earlier it is displayed, na? The mouse is kept there only, na? The mouse is there only. It's there, na? So everywhere it is, everybody see the Excel sheet or not?
Excel sheet is clearly visible.
Yeah, the everywhere formula is there, na? See, 24 gauge, 22 gauge, all formula is there. It automatically show.
Just want to update that this webinar workshop is also being uploaded in our YouTube channel. So
Mm.
after this, anyone can watch this program again.
Mm.
Just you will have to search Delhi chapter of ISRE in YouTube. You will find all the previous webinar as well,
Okay.
including this one.
So,
So if you have wall mounted grill within 1 meter, just if we have wall mounted grill within 1 meter from FCU such like hotels, guest rooms, whether we can apply only acoustic insulations where acoustic will affect FCU is static.
see, I already told you this is only for AHU with ducting. FC and all small things, and I already told you in the starting. For ducted indoors and the small FC, it's not because it is less static, 12 of 2 static. The throw is very in FC and all. Only thing that the person in the hotel has to feel the temperature. He is not bothered whether getting air or not. As the room is cool, he'll be happy. So in those things we cannot discuss. I'm only talking of the air handling units with ducting. As a air washer, air handling, whichever you say, where duct is there, plenty going all around the premises. You're talking about that.
Mm. How to design supply and return duct then near to achieve. I think we have taken this one. How to CFM and motor speed related. When to choose 1440 RPM or 960 RPM when motor speed is say 1200 RPM.
See, that's what I told you a few minutes back in the discussion. When you have to demand the fan selection from the fan person or AHU person. Okay. Now, as long as the fan RPM is very close to the motor RPM, motor RPM I told you 2 pole, 4 pole, 6 pole, 8 pole. So as long as the fan RPM is close to motor RPM, you can go for a smaller pulley and your friction losses on the belt loss is less. If you go for suppose your fan RPM is say 930 RPM and you're going 1440 RPM, the belt loss will automatically accumulate for that speed reduction. But instead of 960 RPM, you go 930 RPM fan, very close. The belt loss we can have, and you can run at 960 also, no harm in that. So it all depends on if you demand the fan selection from the supplier and choose the correct motor, it will be fine. Otherwise, it's not possible. Anything else, sir?
Return air is 1.5 times more than SA supplier. I think SA means supplier. Is it correct?
No, it's not like that. It's people have the practice of doing it. It's not actually not like that.
How to size plenum? How to calculate friction loss in masonry duct and the underground mine wall?
How to connect the
How to uh, how to calculate friction loss in masonry duct and in the underground mine wall?
see everywhere the same thing. Only friction factor varies. That's all. It's only friction factor. For GSU to have some friction, for cement you have some friction like that. If you have, the only thing you have to go for friction loss. That is, you got a coefficient. If you put the coefficient, you'll know. That's it. Formula is same. The coefficient varies.
Why velocity reduction method not being used widely for duct sizing?
Simple. I told you fostering already fixed height by the architect. So what he will do? He will this much only fostering. You have to play in that. So you have to play. That's what actually happening. The people are not taking concurrence from the AC people. They have to take concurrence from the AC people and give adequate space for the fostering so that how that can be put in a proper way. But it's not happening.
So I think we have well taken with all the questions, sir. I think this is one of the session when we received maximum number of questions. So
Oh,
that shows that how audience were involved with us. That
okay, okay,
a positive sign we look forward.
okay,
And
okay.
all the question has been well taken. Somebody were asking for the PPT, so we will ask the committee and program chair
Oh,
if they will allow with consent of yours as well.
yeah.
So we will share the PPT. So I think there is not to worry. This program is live in YouTube as well. So all the materials will be immediately available in our YouTube channel also. So I think immediately this program will be available in the YouTube.
Mm. Okay.
So
Any verbal feedback from any audience, any participants? Or do you want to have
so they can one hand raise is there. So I'm going to allow.
few people, not much. Few people can just share their questions
So
or some
should I
views.
allow him to talk here? I mean,
Yeah, few people can talk. Few people, not
yeah.
all.
So we'll take few people's only, two or three.
Yeah. Hello?
Just a minute, sir. Yes, Mr. K. Tirukanvam.
Pranav Karasu.
Yeah, Rasu. Yeah, please ask your questions. Yeah,
Yeah,
please go ahead.
good evening. Can you hear?
Yeah,
Yeah.
absolutely fine, sir. Please go ahead.
Okay. I'm not asking questions, but the program went well. I
Oh,
thank Murli Khan sir for
oh,
your excellently conducted. Also, Delhi chapter for conduct these excellent programs. Thank
Thank
you.
you very
Thanks a
much, sir.
lot.
Yeah.
It is from
oh.
Madurai. Yeah.
Okay. Thank you.
First
Thank you.
RD. First RD.
Okay. Thank you. Thank you.
Thank
Thank
you.
you.
Thanks a lot. Thanks a lot.
Mr. Somitra Banerjee with us. Yeah, please go ahead, sir.
Good evening, sir. It was. Am I audible, sir?
Yeah,
Yeah,
yeah.
you're fine.
Sir, good evening. It was a enlightening session for us. Like we could at least brush up our knowledge what we had been taught in our initial days. Sir, I mean you had clarified two three queries, but I had another two actually, sir. If you allow me, I just want to get it clarified, sir.
Please, please.
Sir, in the ideal air terminal location, you had shown three scenarios.
Correct.
And in the in the second scenario, what is what you have shown therein, I could see the zigzag location of the air terminal has been shown.
Correct,
But
correct.
in generally, what happens is that, like, when we deal with high glass area,
Hmm.
wherein we have peripheral
Hmm.
huge heat load, we
Hmm.
go for when in a perimeter zone we select a zone and we place the air terminals
Hmm.
near to that zone,
Hmm. Hmm.
and return we collect from the inside. So
Yeah.
sir,
Hmm.
I just wanted to get your feedback in this case, like, what should be the ideal way.
Okay. See, I have been discussing with n number of architects. They always there is priority to architects and less to the AC people. See when it looks to be very aesthetically nice on one side having the supply long grill and I say the long grill. I see aesthetically, but the big hall, the center core hall will be warm because you don't have adequate airflow in the center hall. This is what I've been begging to people, please don't go that. But they know aesthetics is very important, lighting, these, there, fancy things. I mean, the importance to given architect is very, very high compared to designers. Somehow we have to first make them aware these things and tell them what is what. We have to make them. We have to explain the importance of energy saving and importance of unbalanced air distribution. Unless we put efforts and tell them this will be always like that only. But I am not in for it like that. I always want to have a uniform distribution. Always a linear, lengthy grill on one side, supply lengthy other side. I am never for it. But I am forced to do it because the client and architects are on one side of the table. Technically, I am not agreeing. Okay, next, please. Anything else,
Yes.
sir?
My last question, sir. This another scenario what you had shown for return air duct. What you could see is there is a like condensation case because of the leakage in the return air space.
Correct.
I work in IIT Kharagpur as a civil engineer, so I could. We are currently also we are facing in one of the site the same problem.
Mm-hmm.
Uh, Sir, one thing is probably during heat load, what you had indicated that probably the load has not been considered in the return airspace. So that's
Correct.
why this condensation is happening, because there's a huge
Energy loss.
reporting of condensation. Actually,
Correct.
equipments are
Correct.
getting flooded.
Correct.
So, sir, what would be the easiest way to deal with it, sir?
Simple thing, first of all, put return duct. Don't say no. Put return duct.
No, there is no
But
space, sir.
yeah, that's the problem. No? They first decide the fast selling and ask you to work on it. That's what happening. We have to make some innovative ways to pull that out. Only by seeing the drawing, I think we can give some ideas. That's it. You have
Correct, sir.
pick up points at multiple locations and bring out of the building or something. We have to think.
Thank you, sir. Thank you.
Thanks.
Thanks a lot, sir. Kindly request, I'll request, last request, sir, kindly share your contact details so that we can be in touch with you, sir. Thank
Yeah,
you.
fine, fine, fine. And anything else, sir? Tapas, sir?
Mr. Mohan Dutt is there.
Yeah.
Hello, Mr. Mohan Dutt Sharma. Hello.
Can you hear me?
Yeah, yeah.
Yeah, please go ahead. Yeah.
Yeah, first of all, I thank Mr. Murli for the nice session. And you were talking about the sizing of the supply duct and the return duct.
Hmm.
I understand the return duct will be a little higher in size than the supply duct, because the reason being the temperature of return air will be slightly higher, which will raise the volume of the uh, return air, and that higher volume will pass and the lower area of the return, but considering the velocity to be same. Am I correct?
Actually, theoretically, people say, but actually it is not. See, the expand. It is not a compass jack. It is only a normal. So
Yes, yes.
it is only fan draft is acting, not a compass jar to expand multiple times when you expand it with temperature. It's only a ambient air with slight reduction in temperature while on going and slight increase while coming. Okay. hardly 2 or 3 degree, roughly 5 degree maximum worst case. Okay, so that doesn't give huge expansion exponentially or whatever the thing is. So the CFM, that is, we actually talk of mass of air, not the volume of air. Okay, the mass of the air only defines the heat load, not volume of the air. So return air will definitely pick some condensation or heat load. So mass of air will be slightly higher because of the, if at all it picks some moisture. Okay, the mass of fire only is important. So the velocity by increasing by 1000 fpm to 1200 fpm, duct size will go a little bigger. But technically, there is no advantage or disadvantage except for the that cost. If at all the size goes one size higher, if at all. Instead of 22 gauge or 24 gauge, that may be slightly, maybe a factor in cost. Otherwise, technically, the absolutely because for small delta increase or decrease in CFM, the duct aspect ratio and length of it doesn't go very high. You can see for yourself, few fractions doesn't matter. So
Okay.
I can have the same supply and return, no issues.
Okay. So by putting the return duct, we may have a slight increase in the initial cost, but the operational cost will be a little bit lesser compared to when there is no return air.
See there are two different things. Return and duct, you should put or not put. If you're putting return and duct, it will be a cost. But
Yes,
same time, it is any saving the because it doesn't pick unwanted air from different sources.
yes. So it will give the cost saving in terms of the energy saving.
Yeah, OPEX will come down. Correct.
Yes. So the operational cost will be a little lower if we put the return air. That will compensate the initial cost.
Correct. Within few months, not years, few months it will compensate.
So we should always go to put a return air.
Correct.
Thank you.
Okay.
So I think, sir, we have taken all the question and you have answered very patiently.
Okay. Good.
So I think now we are coming to the end. Before coming to the end, I have sent you the link to join ISRE, and one browser link is also there that will help you to take quick decision why you should join ISRE. As you know that we are the Society of HVAC in our industry, which is disseminating knowledge from the last 40 years, and of course this is going well in the future, for future as well. So when the members joins us, this boost ups to make this kind of program again and again, and this is the only moral boost up thing. So we request everybody, one who is non-member here, to join ISRE. When you go through the link, you will have to just select Delhi chapter of ISRE, then formal details will be required to fill up from your side, and then a payment link will be there. There are nominal fees, 7,500 plus taxes for the 3-year membership we have. And after having the payment, you will be get the kit and all things within a week, 10 days from the headquarters side. So this is very normal process to join us. And as you know that there are no any other society like ISRE, I mean, in this area. So definitely there is a large networking opportunity, having great events like ACREX, RefCold. In Delhi, if you talk about ACRICOMF is there, VENCOM is there. We are going to organize large cricket programs as well. AGM, ISRE Nights, many things we have planned. And of course, this kind of online programs is there in the form of workshop and all. So you will get good opportunity to embellish your network. So definitely membership will boost up your network in the business opportunity sense as well.
My last point.
Yeah.
I really thank Western Ducks, the sponsor, for coming up with this event. In fact, I requested them if it's possible to sponsor, and they
Yeah, of course.
consider to my request. I really thank them.
Yeah.
And one more point I would like to add is nowadays we are looking for non-conventional energy. So I think ISRE should be able to come out with some programs non-conventional energy also if possible, using non-conventional energy to run AC. Okay, I mean that way. Okay, like we have this wind and solar, all those things. So there should be some all these people who are in this industry should be able to gradually move to use of non-conventional energy also to run the AC. AC is the biggest load in the globe. So
Mhm.
some innovative ways should be dug out to make ACs run on the non-conventional energy. I think we can all do some brainstorming on this and collectively come up with some innovative ideas, try them and use them. Thanks to all the participants, and I request to take part in the subsequent programs also. Whenever Ishri is giving me a chance, I thank Ishri also for this opportunity to give me this program. It's my third program with Ishri Delhi, and I look forward some other programs in the coming days with Ishri Delhi. Thank you, Delhi Ishri, please.
Yeah. Thank you, sir. And definitely, as you said, that non-conventional energy will look forward for this kind of program as well. And we request you for all the attendees that you can share your feedback and other program topic as well, that what they are looking for, because from our mindset we are making the programs, programs under the guidance of our program chair. But audience and attendees feedback are also very important to align their uh, visions or expectations as well. So thank you. We are again thankful for Western Air Ducts India Private Limited to for sponsoring this program, and also all we are thankful for annual partner, and of course we are grateful towards Mr. E.R. Murlikant, our speaker for the day, and all the attendees as well. So it's uh, perfectly, we can say that we have conducted one more successful program under the banner of Delhi chapter of ISRE, and it was going well. So final line with you, sir, only then we will close this program.
Yeah, I think it's quite a interaction with everybody. The participants were enthusiastic, and this gives me more feeling to get into more and more discussions like that. I thank the participants for very interactive. Yeah.
Thank you very much, sir. So with your permission, should I close this
Yeah, please, please,
session?
please.
Yeah. Thank you very much, sir. Thank you, everybody.